I want to keep talking about how we can use that idea of a factorial when it comes to making choices out of a certain group of things, if a certain number of items, if you're choosing some of those, how factorials can help you decide how many choices you have. And so we're going to go back to those formulas that we referred to a couple days ago. And I'm going to tell you what the letter P now stands for, which I did not tell you before. And so this stands for something called a permutation. Now, most of us know what a mutation is. Okay, a mutation is when you take something that's normal and then it mutates, okay, so into something different. A permutation is where you start out with a normal group of things, but you pick out different combinations from that group. And so that is called a permutation. What it means is that you start with n options. From those n options, you're going to choose R out of them. And in a permutation, order matters in how you choose things. In other words, there's an advantage to being chosen first, as opposed to being chosen second, third, or fourth. Okay, that is super important here, right? That there's an advantage to the position of your choice. All right, so in which the items are chosen, there is an advantage. As opposed to the NCR formula, and the C stands for combination. And in a combination of things, you also start with n options. You choose R choices. But the order in which you make your choices is irrelevant. There's no advantage. So I want you to think about, like, oh, let's say going to Chipotle, right? And so everything's in front of you at Chipotle and you've got to make your choices and tell them, okay, I want, these kind of beans and this kind of rice, and I want heavy on the guac, I want the salsa, okay? So you make all your choices, but ultimately the order in which you make those choices, if you tell them beans before rice or rice before beans, it's not going to matter. It's all getting dumped into the burrito anyway and mixed up together. And so the order, you are making choices, but the order in which you make your choices doesn't matter. Okay, or you go to a Panda Express and you're ordering a combination meal. And so you tell them, I want Kung Pao chicken and I want beef with broccoli and I would like the sweet and sour shrimp. Okay, the order in which you tell them those things doesn't matter. You're just going to get your styrofoam box. It's going to have everything in it, and the order is irrelevant. That is a combination. So think about a combo meal where the order doesn't matter. But if I'm awarding prize money and I'm going to pick my 3 favorite students, and my favorite student that I pick first is going to get $50, and my next favorite student's going to get 25, and my third favorite student's only going to get 10, the order in which I make those choices does really matter because there's an advantage. So that is the difference between a permutation and a combination. So I want to do a couple examples with you. So every time you have to ask yourself, in this situation, when I'm making the choice, is there an advantage to how the choices are made? So let's talk about a car race. For example, let's pick a real famous one, the Indy 500 car race. Okay, and so in the qualifying round, there might be 15 cars on the track, and the top 5 qualify. No, the top 3 qualify to move on. And so we want to know, how many ways can that happen? How many different outcomes could there be? Well, is there an advantage to being in the top 3? Is there an advantage to being first versus third? And the way this is set up, this is just qualifying. The first one qualifies, the third one qualifies. There's no advantage if you're first or second or third. They all equally qualify to move on. So this would be, because the order is irrelevant, this would be a situation where we would say this is a combination, so it's 15C3. And we would work that out using the combination formula, which is 15 factorial over 15 minus 3 factorial. And then we also tack onto that, I didn't make it long enough, 3 factorial. So this is 15 factorial over 12 factorial, 3 factorial. And so we've been working enough with factorials to know that 15 factorial, 1, 2, 3, up to 12, 13, 14, 15 at the end. And then the bottom would have 1, 2, 3, up to 12, but then it would start over with 1, 2, and 3 again. And then we work on reducing. So the 1 through 12s reduce, and I'm left with 13, 14, 15 over 1, 2, 3. The 3 reduces in the 15 to give me 5. The 2 reduces into the 14 to give me 7. So overall, I'm left with 13 times 7 times 5, which then you'd grab your calculator to evaluate that to find out how many possible outcomes there could be in this Indy 500 race. So now let's move on to the finals of the Indy 500. All right, in the Indy 500, now we're in the final round. And there are 12 cars. And the top 3 get prize money. And the prize money is awarded according to how they finish. And so the first place would get more prize money than the second, than the third. So when we ask yourself the question, does the order matter in how they finish? Is there an advantage? And the answer is yes, absolutely. There is an advantage within the top 3. There's an advantage to being first, second, or third. So this is going to be a permutation situation. So 12 P3. And so this one would be set up as 12 factorial over 12 minus 3 factorial. And because it's a P, there isn't that extra factorial in the denominator. So this would be 1, 2, 3, up to, say, 10, 11, 12. And then the denominator, 12 minus 3, turns out to be 9. And so this would be 1, 2, 3, up to 9. And so the first 9 terms would reduce away, and we're left with 10 times 11 times 12, which ultimately is 1, 3, 2, 0. So the Indy 500 could finish in 1,320 different ways. So we're counting up the number of outcomes that there could possibly be. All right, let's do one more example. There are 15 seats in a room. There are 15 people. And I want to seat them randomly. So I'm allowing these people into the room and they are selecting it randomly. The word randomly is your clue. there is no advantage to the seat that you choose. Okay, it doesn't matter how the seats are assigned. And so this is a C situation because the order doesn't matter. So that would be 15 and 15. So we'd set that up as 15 factorial over 15 minus 15 factorial times 15 factorial. So we end up with 15 factorial over 0 factorial, 15 factorial. The 15s both reduce. We know that 0 factorial is 1. The answer is 1. There's only one possible outcome here. But suppose that you have 15 seats and you've got 15 people, but the people who sit in the front 5 seats, okay, suppose that they're, guaranteed some advantage. If you sit in the front, the likelihood of your grade going up is 10% or some advantage to being in the front seat. Or maybe you're at a theater and boy, yeah, or a concert and you want to be in the front seat. Okay, definitely an advantage to being in the front. So if there's an advantage, then we're talking about a P situation. So 15, 5. So that would be 15 factorial over 15 minus 5 factorial, or 15 factorial over 10 factorial. And so the numerator has 1, 2, 3 all the way up to 10, 11, 12, 13, 14, 15. And the bottom just has 1, 2, 3 up to 10. And so the first 10 numbers, whoops, I didn't mean to cross out the 11. The first 10 numbers all reduce, and I'm left with 11 times 12 times 13 times 14 times 15. And then you would grab your calculator to evaluate what that is. Okay. So overall, the ultimate question to ask yourself in all of the word problems that you're going to look at, is there an advantage in the things that are being selected out of this group? Is there an advantage within the selection? Okay, the position that you're. So if you're having trouble with it, that's what you need to ask yourself each time. All right, so you'll see how factorials work in making choice selections. And then Friday, service day. So I encourage you to just go all in on Friday. Find a way to bless somebody in the household that you're living in, or in your neighborhood, or in a greater community like that. And then we'll check in together next week.